Imagine walking into a library containing 3 billion pages of text. This isn't fiction. It's the reality inside every single cell of your body. Your DNA is the ultimate instruction manual, written in a simple 4-letter alphabet: A, T, C, and G. This code is a microscopic masterpiece, building the ladders of life that make you who you are. Every second, millions of your cells copy this immense blueprint with jaw-dropping speed and precision. It is a nearly flawless biological machine, mapping out the architecture of human life. But what happens when the perfect machine makes a mistake? But sometimes that flawless machine falters. Deep within the core instruction, among billions of letters, a single base pair own tiny typo is all it takes. The code is corrupted, and a single wrong instruction cascades into systemic breakdown. These mutations are the root of thousands of complex genetic diseases, from sickle cell anemia to cystic fibrosis. For centuries, this flaw seemed impossible to edit, an unreachable error that we could only observe, never fix. This single typo is the challenge science had to overcome. To solve this problem, scientists didn't invent a solution from scratch. They borrowed one from nature's most ancient battleground, the war between bacteria and viruses. For billions of years, bacteria have kept a microscopic filing cabinet of genetic mugshots from past attackers. This system is called CRISPR. When a virus attacks again, the bacterium crafts a specialized molecular machine called Cas9, a set of programmable scissors. By loading the stored genetic mugshot directly into these scissors, the cell creates a weapon that can seek out and destroy the invader's code with absolute precision. And that got human scientists thinking, what if we could use these scissors ourselves? Human scientists realized we could harness this biological system for our own benefit. By creating a custom-made strand of guide RNA in a laboratory, we can program the Cas9 tool to target absolutely any genetic sequence we choose. We can send these upgraded molecular hunters deep inside the massive informational maze of the human genome. The tool scans past billions of letters at incredible speeds, completely filtering out generic data until it locates the exact typo responsible for a disease. Once it aligns perfectly with the target, the molecular machine unzips the strands and readies its cutting edge. We are no longer just looking at the code. We are about to change it. With the trigger pressed, the molecular scissors perform their work with absolute accuracy, snipping out the damaged base pair and releasing the typo from the strand. But removing the mistake is only half the battle. Left to itself, the cell will attempt to blindly patch the gap, often causing further damage. To ensure a perfect repair, scientists provide a custom template, a flawless genetic block containing the correct letter. Guided by this template, the cell's natural repair machinery locks the perfect tile into place, permanently binding the helix back into its healthy structure. The code is rewritten, the blueprint is cleared, opening up a completely new horizon for human medicine. But with this immense power comes an equally massive responsibility. CRISPR technology forces us to look in the mirror and ask tough ethical questions. Where do we draw the line? Are we simply curing devastating hereditary illnesses, or are we opening the door to designer enhancements that alter the human experience forever? The decisions we make today will echo across generations, rewriting the very future of life itself. This tool is no longer science fiction. It is a reality that requires global wisdom, careful regulation, and unified humanity. The book of our future is wide open, and for the first time in history, we hold the pen. Thank you for watching.